Hey 8th graders, today we're going to be combining lessons 2.3 and 2.4 from Magnetism. As the last couple of lessons we've done, you will be filling out nothing in Amplify. It'll all be done in this PowerPoint. Obviously you guys noticed the video down here on the first slide. Your learning targets for today, we have a couple and you're going to see them. They're all very similar, but you'll see them throughout this lesson. I can model when energy is the highest in a system of magnets. So we're really going to be focusing on this kinetic and potential energy piece and how we can change those energy values versus in attracting versus repelling magnets. Okay, I can identify the change in potential energy when magnets are moved with and against the magnetic force. So we're definitely going to talk about what that means if we're moving something with a force, because that looks different in an attracting system of magnets versus repelling magnets, and again, against that magnetic force. And then finally, I can manipulate a system to increase its potential and kinetic energy. So you guys, again, will focus on that transfer of energy between potential and kinetic. And this all kind of ties back to that video we watched earlier about the magnetic launcher for the spacecraft. Again, we're not really going to focus on that concept, but if we're looking at trying to get more kinetic energy into the system, how can we do that with magnets? Okay, so first things first, let's add key concept number 5 into your notebook. The energy used to move a magnet against a magnetic force is stored as potential energy in the magnetic field. So we'll be able to, again, tie in that learning target we had of seeing what happens to our potential energy when we move it against and with magnetic force of a system of attracting or repelling magnets. Okay, so for your first little warm-up activity, you have a modeling activity to do. So on the next slide, you will have your modeling tool. And your goal is to create a model to predict how potential energy and kinetic energy change. So we're kind of getting your guys' thoughts beforehand, and then we're going to move on and see if we can't change your guys' thoughts. So what you will do is shade in the bar graphs under each panel to show how much potential and kinetic energy you think the system has at each moment. And then instead of annotating, you guys are just going to write a caption for your model. So here's your model. You have just a single magnet. So you guys will go ahead, click on your draw tool up here, choose a pen. You might need to click on the slide if your pens are showing not showing up. Once you click on the slide, they should show up that you can use them. And then again, you can change color if you choose. You guys will shade in these blocks underneath based on how much kinetic energy you think. So that might work, or if you guys choose to use a highlighter, that might work a little bit better for you guys. So you'll let me know how much potential or kinetic energy you think is in each of those. I'm just filling in random stuff right there, so don't copy that. Okay, so do that, and now we have two magnets held in place. You can see that the south ends are pointing towards each other, so at this point we know that those are going to repel. And then we're holding them in place. So how much potential energy do you think that system has? How much kinetic energy do you think it has? Remember that they're held in place, and kinetic energy is energy of motion. So I want you to think about that. And then as we release them, so immediately upon release, those seconds where they're starting to move apart from each other, what potential energy do you think there is in the system, and how much kinetic energy? And then go ahead and just write a quick little caption for this image explaining the image and how the potential and kinetic energy change. Should be fairly brief. Okay, moving on to activity 2 is a little simulation for you guys. So this is focusing on that second learning target that states that I can identify the change in potential energy when magnets are moved with and against the magnetic force. So this can be kind of a hard concept for some people to understand. But when we're looking at a system of magnets, so one or more magnets, you want to think, all right, if it's an attracting system, if we're moving it with the magnetic field or the magnetic force, we're doing what the magnets naturally want to do. So with two attracting magnets, they naturally want to come together. So by moving one magnet closer to another, we're moving it with the magnetic force. If we're doing what the magnets don't naturally want to do, then we're moving it against. Okay? Opposite is true for repelling magnets. Naturally, repelling magnets want to move apart from each other. So if we take a magnet and move it further away, we're moving it with the magnetic force. And if we take a magnet and we try to move it closer, we're moving it against the magnetic force. Okay? So on this simulation activity, you guys are looking at these two claims here. So potential energy increases when a magnet is moved with in the same direction. So again, moving with what the magnets naturally want to do, the magnetic force, versus claim B says potential energy increases when a magnet is moved against. So doing the opposite of what the magnets naturally want to do. So one partner will test, so you guys can ignore this part about the partner. You guys are going to be testing both of these claims on your own. Okay. Activity 2 simulation is attracting magnets. So you guys are going to be setting up your simulation with attracting magnets. So create a system of attracting magnets that are a medium distance apart. Record the initial potential energy in the first column of your table. So if I go back, click on my sim link on the last slide. Remember, you can right click. Oops, don't forget to go off your cursor. You can right click and open your link. And it, again, might direct you through Clever to sign in if you haven't signed into Clever or Amplify recently. Okay, so back to our directions. Create a system of attracting magnets that are a medium distance apart. So I want them to be attracting. I'm just going to take 2 strong magnets. Medium distance is probably about that much. Closer or further away, either is fine. You just want to be able to move them closer and to move them further apart. We can also click on this toggle line up here to show the field lines. So again, moving it with, they have connecting field lines, so we're going to move them closer together to be with their magnetic force, and against would be to move them further apart because that's against what they naturally want to do. They don't want to move further apart. Okay, so we've created our system. I'm going to go ahead and run my system and then click Analyze. And I want to go back and just see what my potential energy looked like before. So that's going to be our initial potential energy. So if I drag this back to the start before I release the magnets, looks like my potential energy was about 7,001 joules. So I would plug that in right into this box here for my initial potential energy. Step 2 says move the second magnet with the magnetic force, so with it. So we want to do what it's naturally wanting to do, and in this case they're attracting, so they naturally want to come together. So for my second test, I'm going to go back to build. And I'm going to reset my magnets closer together. Okay, so they can be even a little bit closer here. And I'm going to go ahead and run that. And then analyze. And take a look at what my potential energy looked like. So it looks like it's actually a little bit lower when I moved it with. Okay, and so I'm going to go ahead and plug that in there. And then finally, my last little direction here is to move it against. So I'm going to move it further than it was when I first started. So I'm going to move it maybe this far away. Okay, so now again, same thing, run it, analyze, and then drag it to the beginning to just see what my potential energy looked like when it was further. So you can see it's about 7,105 joules. So I would record that in there. You're going to do the exact same thing, but with repelling magnets. So again, remember that if you're moving it with, you're doing what it naturally wants to do, and magnets naturally want to repel. So you're going to be moving that magnet away to get that second piece of data. Okay, you can use your same piece of data. I guess you have to do repelling magnets. You can't use the same piece of data, excuse me. So get your initial potential energy of those 2 repelling magnets. It's pretty easy just to flip one of those magnets so they're repelling. And then again, move them with, so you're going to move those magnets further apart to start and then closer together to move them against their magnetic force, and then record those 2 potential energies. And then think about it. All right, so yes, we had a different system. Attracting and repelling are definitely opposites. So when we move them closer or further away, those are definitely opposite on those 2 systems as well. But the with and against are the same thing. So remember, we're going with what the magnets naturally want to do or against what the magnets naturally want to do. So what happens to the potential energy when we move them in the direction they naturally want to go versus moving them in the opposite of the direction that they naturally want to go? Okay, so you're going to answer questions to that on this following slide 8. So my evidence support the claim or claims that potential energy increases when a magnet is moved with, so again in the natural direction of the magnetic force, or B was against, so moved opposite of which what the magnets naturally want to do. And then explain how your evidence supports the claim or claims. For a good explanation, you guys really should include some data from your tables. So look back at your 2 data tables and use some specific pieces of evidence from there that support your answer. So if you're saying they increase the potential and energy by moving with the force, then give me some numbers to prove that. What was your initial and what number did you see when you moved it with that provided that evidence for your statement? If you think they moved against and increased with the against notion, then again, look at your 2 numbers for against in your data tables and compare them to your initial and use that as your explanation. Okay, moving on. Part 3 is modeling. This is a little easy section for you guys. right here you have a diagram that shows us, all right, here's a single magnet with its magnetic field lines. You can see the amount of potential and kinetic energy. Now we have two repelling magnets, and you guys can see what their magnetic field lines look like. And you guys can also see that they have a high amount of potential energy and no kinetic energy. They must be held in place. And now that these have moved or are moving apart, we have a little bit lower potential energy, but we also have a value for our kinetic energy. So read through these 6 options. So we have potential energy was stored in a magnet, a force converted potential energy to kinetic energy, the magnets were released, a magnet was moved against a force, potential energy was transferred into the system, or this is not a system. Okay, so you guys will go ahead and label. So let's just take a look at the first box. Right now you only have one magnet there, so that technically is not a system. You need more than one part to consider it a system. So F would be the correct answer there. So you guys can either use your draw tool to draw an F in there, or you can come over here, click and drag your F, and drop it right into that box. Okay, so 2 options there. That's up to you guys, but F is the first answer for this first box. Okay, so F is no longer an option. You guys can now look at A, B, C, D, and E to fill in these other boxes. Okay, moving on. You guys have this exact same, and I just kind of explained this to you guys, where you have no potential energy and no kinetic energy because you do not have a system right here. However, we have developed a system of repelling magnets, and you guys can see that they're held in place. They have a high amount of potential energy, okay, because they're really close together. Because they're being held in place, we have a lot of stored energy. They have a lot of ability to want to move. We just haven't let them move yet. And then, of course, after release, we've let go of those, and we've noticed that some of our potential energy has been lost as those magnets move apart, but also it's been converted into kinetic energy because those magnets are, in fact, moving. Okay, last activity here. You guys have a little simulation activity to do. So it says place one weak magnet. If you guys already have your simulation open, great. If not, here's the link to the simulation. Right click it and open. So in this, we're going to go ahead and rebuild. And it says place one weak magnet toward the left of the screen. So this goes back to a couple lessons where you guys built, I believe it's 1.5. You guys were, no, 1.3. You guys were to build a magnetic catcher and a magnetic launcher. Okay, you guys are going to be focusing on this repelling launcher theory. Okay, so if we were to try to make launch a magnet and watch that conversion with potential and kinetic energy, how can we increase those levels? So place one weak magnet towards the left of the screen with its north pole facing up. So here's this. Okay, there's my weak magnet. Lock this launcher magnet in place. So this weak magnet is going to be our launcher. Okay. Place the second weak magnet, the spacecraft magnet, to the right of the launcher. So this is going to be the object that is getting launched. So here's another. With this north pole facing up, again, that's going to have us be repelling. And then position the spacecraft magnet indicated in the number of grid points away from the launcher magnet. So let's go ahead and take a look on our next slide. So we're going to need to do 4 different distances away from each other. So the first one will be 4 grid lines. So right now we just have three grid lines in between. So I'm going to go ahead and move that over 1 more. So here we have 4 grid lines in between. Okay. And then we are going to record our initial potential energy. We're going to press run and analyze, and also record those as well. And then we're going to go and do the same 2 steps, but with the closer distances. So we're starting off at the farthest away. So I'm going to go ahead and hit run. And then analyze. It took forever. And I'm going to go to my beginning to see what my initial potential energy was. So when those 2 were held in place, we had an initial potential energy of 2,722 joules. So I'm going to go into this. My potential energy before was 2,722 joules. So I'm going to plug that in there. And then again, potential energy after. So at the end of this, we can drag clear to the end of our launch. After we had 2,581. And then our kinetic energy was 141. So you'd put in the 2000 number right there, and then 141 right there. Now you're going to move them one step closer, go back to build, and we're going to do 3 grid lines, or grid points apart, okay? You're going to do the same thing for that, and then the same thing for 2 grid lines apart, and you're going to run and analyze, test those, and record your data, and then answer these 3 questions. So when does the system have the most energy? What energy conversions did you see? So if we're talking about conversions, you remember it's changing from one type of energy to another. So what conversion or conversions do you see here? And then which test resulted in the greatest amount of kinetic energy? So again, you ran 3 tests all at different distances apart. So was it the 4 grid points, the 3, or the 2 grid points? Okay, finally, do your wrap up. Do you have any questions? Yes or no? Obviously, if you have a question that's preventing you from finishing this assignment, you guys want to hit me up in Teams right away so I can help you out. And then use your draw tool to circle 4, 3, 2, 1. Let me know how you did on this assignment. And finally, you are all done. Make sure you're complete and turn it in. I hope you all are having a wonderful day, and I'll talk to you soon.